Okay, today we're going to learn about combining like terms, so get your notebook ready.
However, before we teach you how to combine like terms, we need to make sure that we get our vocabulary. And vocabulary is key to making sure that you understand the math concepts.
All right, first vocabulary word is equation, and an equation is a series of terms that have an equal sign involved in it. So that's where equal, equation.
This may be a simple equation, but there are a lot of different vocabulary terms that you will find from it. For instance, whenever you have a number multiplied to a variable, we call that number in front a coefficient. Coefficient. So the 4 here is a coefficient because 4 times x.
All right, here's a word you know already, variable, ding, ding, ding. You know that when we don't know a number, we give it a letter as its identity until we figure it out. And we just call that a variable. We give it any letter X, Y, Z, whatever. We call those variables.
We only have 2 more. The next one, you guys are used to calling them plus and minus. However, if you were actually going to name these, we call those operators. They tell us what operation to do.
And finally, a constant, meaning always, it's always that. A number on its own is called a constant because it's nothing changing. Like here, we know that that's a variable. It could change, but 5's not going to change. 5 is going to be 5, constant. 7's going to be 7. He's not going to change, constant. This one, 4, can change because he's being multiplied by a variable, so he's not constant. Constant, constant. There's nothing that's going to change him.
I lied to you. There's more than 2. Our last and final vocabulary word is what we're learning today, terms. We need to make sure that we understand what a term is. Now, a term is any of the following. So it's anything that's being multiplied by a variable or a constant by itself. Those are terms. So in this equation up here that we've been using, we actually have one term here, one term. Notice I keep the operator with the number that follows it. And actually, oddly enough, this is a term. The only thing we never box is the equal sign because that's a special symbol.
Okay, so what we wanted to work on today, now that we've inundated you with vocabulary words, we wanted to look at combining like terms. So first we need to really look at what terms are in our equation. So here's our first equation.
3 plus 4 equals 7.
All right. And so we're just really going to look at how many terms are here, and we're going to practice boxing those in. So here's our first term boxed in. Now there's no operator in front of him. We can put one because we know that the 3 by himself is a
Positive. Anything that doesn't have a negative operator is automatically a positive operator.
woot woot. All right, and then the next term is this positive 4 that's hanging out there.
And keeping that operator with it.
And finally 7, which is a
Single term. Monomial.
and a positive.
Oh, and it's also positive. I like monomial better. So the first step, as we said, is to find the terms. How many terms are there? In this case, we have 2 on this side and 1 on this side. So really there's 3 terms in this equation. But if I were to really look at it, I would be only looking at this side, which we call an expression. In that expression, we have 2 terms, which is binomial. But for the purpose of today, we want you to find all of them in the whole expression. So the answer here would be 3 terms in that equation. Probably just confused you. You might want to soak that in. Let your mind be blown.
All right, now that Mr. Sanchez has blown your mind, let's shrink that up, toss it off to the side in your memory bank. Woo, woo. All right, so example 2, and we're just going to focus on boxing off our terms. So let's look at example 2. We've got 3 plus 4x equals 10. That's our equation. And all we want you to do is box off your terms, give them an operator if they don't have it, And then tell me how many terms you have. So here we have 1 term, 2 terms, 3 terms
In that equation.
in that equation.
If me and Mr. Sanchez ask, what would you call that as an expression? You should be able to say 3 plus 4x is the expression, and that is a binomial because there's 2 terms in that expression.
Ooh, big words, blowing your mind.
We all know what bi is, bicycle, binoculars, binomial.
Bi meaning 2. 1, 2.
That would be dose, Bryant, dose. All right, for this next one, what we're going to want to do is we're going to go ahead and take that, shrink it, add it to our collection of things over here, things to think about. But now I want you to pause it. After I've written down the equation, I want you to pause it, and then you come up with how many terms are in that equation and be ready to check your answer after we go on. So our equation this time for example 3 shall be 4 times x plus 2 times z equals 5 times x plus 3. So pause it right now, hold on to it, and then count how many terms there are, and then play it afterwards, and we'll give you the answer.
Okay, not only did you pause it, but did you try it? So hopefully you have it boxed in and you have your, boy, Mr. Sanchez moving stuff. All right, and you have your answer. Do you think that it is? So here's how I would do this. I'm going to go ahead and box my terms off. This is the term for x. This is positive 4x. And positive 2z. Positive 5x.
Don't box the equal sign.
And positive 3, and don't box the equal sign. I almost did. You see, it almost bit me.
So if you did it right, you'll be able to count 4 boxes. 1, 2, 3, and 4. That means you have 4 terms in the equation, which we call a polynomial. Good job.
Okay, another one for the memory bank. Ciao. All right, let's do an example 4. But this time it's your turn. So write that down and box them out and tell us how many terms are in this equation.
And what you're going to do is you're going to tell us how many terms by standing on your chair and clapping that many times. So if it's 7 terms, you clap 7 times on your chair. Don't fall. If you do fall, blame Ms. Sanchez for telling you to do it.
Okay, you've stood on your chair and clapped a certain amount of times. If you got a thumbs up from the teacher in the room, good job. You did it right. If you got a thumbs down, go ahead and reflect on this one and try again.
Oops, that's supposed to be smiling.
Okay, time for your checkup. Let's put these off to the side, off to the side, off to the side. All right. Final one for just identifying how many terms you have. You're going to write this one down. Actually, you don't even need to write it down. Just screenshot this one. And then put that picture into EduCreations or Notability or something. And then box it up. Tell me how many terms there are and bring that to the teacher in the room so they can check it.
So again, box it and bring the terms after you've screenshot it to us.
So now that you know what a term is and you've practiced that a lot, let's combine those little buggers.
So we've defined terms. Now let's define what a like term is. Now when we talk about like terms, it's very important that we understand that they are any integer can be positive or negative, and or, that means they could be and or this thing term with equivalent variables. Equivalent would be same, equal variable. So that means if it's x variable in one, it better be x in the other one.
Okay, so I have this first example for you. Example 1, 4x plus 5x. These are like terms because this term has the same variable as this term. And I put down here something that is not a like term. 4x and 5x squared are not like terms because this guy's got a different exponent. So not like terms. I can put these two together real quickly. Box them off.
And then she would end up with 9x. However, we can't do this because, again, the variable changes the outcome. So that is something we have to be very, very aware of our variables, or sorry, exponents.
Okay, here's another example of like term and not. We have 3xy plus 5xy. X, y, x, y here. X, y, x, y. Those are like terms, so you can put them together.
So putting multiple variables within a term doesn't change it as long as they have the same variables in each set of terms.
So I could put those together. I have a positive 3xy and a positive 5xy, which means now I have a positive 8xy. That's how you would put them together. This one is not like terms because this has 2xyz and this one has 3xz. If it had the y there, you could call it a like term, but it doesn't, so it's not.
All right, let's go ahead and shrink all this and set them off into our memory bank so that we don't forget where we've been and where we're going. But we need to make sure that we take our next example. Our next example will show up shortly.
All right, so here is our expression, because it doesn't have the equal sign, so we're not calling it an equation. This expression, we're going to marry all the like terms. So first thing we need to do is what you did in the beginning of this lesson. You identified the terms. Okay, I've boxed in all my terms. Hopefully yours looks like mine. So there I've boxed in all my terms, and now I'm going to find all of my matching terms.
Yep. So right now we have 6 terms, which we call a polynomial.
And I'm going to look at this. I have a 3x with no exponent here, so I'm going to find any other x's. This x over here. Remember, if it's a variable by itself, it's one of them.
So it has a coefficient of 1.
So this has the, yeah, good, coefficient of 1. So I have a positive 3x. Remember, that's a positive. And a positive 1x. So if I put 3 plus 1 together, I have 4x.
Anytime we combine like terms, really all we're going to be doing is adding or, subtracting if we have negatives, the coefficients of the term.
All right, next one I'll check is 2y. I'm looking for any y's that don't have any exponents, and ding, 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 I have a winner right here. That's a positive 2y and a positive 3y, which gives me a
positive 5y.
Woo, woo.
Why? Because 2 plus 3 is 5.
All right, and finally, my last two terms. I have an integer with no variable and an integer with no variable. I can just add those babies
So we
together.
have 2 constants.
2 constants. 4 plus 7.
And they both have positive operators, so we just add them together.
And so now I'm done. I've married all the like terms, and that's my answer.
So we simplified the expression, 3x plus 2y plus 4 plus 3y plus 7 plus x, down to what it should be, 4x plus 5y plus
11. All right, why don't you go ahead and give this one a try. Push pause, try it in your notes, and then push play when you think you've got it.
Now that you've tried it on your own, let's see if you got the same answer as we did. So right away, I want to box them. I box my 2x, and that's a positive because there's nothing there. I got a positive 3y, positive 6, positive 3x, positive 3, positive 4x squared. Hopefully your boxes are better than that. So right now we have a total of 6 terms. And if we combine them, we look for the x's, right? Let's start with the first one because it's right here. So anything with an x, ding, 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 ding. Here we go. 3x and 2x gives me a 5x positive.
Why didn't you put the x squared?
Oh, see, that's a good question, Miss Sanchez, but it's a square. We said that you can't have exponent. If there's an exponent, that means I have to have an exponent on the other. So if this had been 2x squared here in the front, then I could have added those two together, but it didn't.
Oh.
So then we go on to the next thing, which is our y, because we've just checked off 2x and 3x. And we go on to our y. Do we have any y's? No y's. So we just do a positive 3y. And then our last one, we look for anything else. Our next one is a constant, right? A constant, positive 6. And we see any other constants? Positive 3, all right? So we get those together and we get a positive 9. It should have been a different color. And we check those ones off. And unfortunately, we have one term left over here, hanging out all by itself, but there's no other one, so that means there's no match, there's no like term, so we just drop it down into our expression. So we have 4x squared. So now we have 1, 2, 3, and 4, which we call a polynomial. All right, so this equation that Mrs. Sanchez is writing for us, what you're going to do, it goes back to the standing and clapping. You're going to go ahead and combine all the like terms that you see. Once you get down to the simplified expression, you're going to stand on your desk and clap for that number of terms. If you get a thumbs up, great job, go on to the next thing. If you get a thumbs down, you're going to want to go back and reevaluate what you did and see where you went wrong.
All right, now you are at the end of the lesson. Here is your checkup. Screenshot this one, put it somewhere where you can do the work, box it in, marry the terms, combine the like terms, and bring it on over to your teacher so they can check it for you.